So today we'll solve some previous year question asked in JEE Mains. So based on my previous lecture, we'll solve some question. So your first question I'm taking is, so it was asked in 2022. Okay. So before solving this question, I would like to write or discuss one important concept related to this question, that is limit. Take it as a note. X tends to a f of x power n minus c to the power n divided by f of x minus c is equal to n into c to the power n minus 1, where when limit x tends to a f of x is equal to c. Okay, if this will hold, then we can say that the limit of this function will be this one. Okay, here n belongs to q, set of rational number. Okay, so from here we are very clear that when limit x tends to a f of x equal to c, then we can say that the limit of this function will be this one. Okay, so we'll try to relate our this question to this concept. So now I will write the question. Okay, I'm just multiplying minus 1 in the numerator and denominator, so it will be okay. Now when x tends to pi by 4, okay, it will convert to root 2. So root 2 power 7 will be 8 root 2. Okay, so here the numerator will be 0 and the denominator will also be 0. Okay, so if I put pi by 4 in place of x, then sine 2x will be sine pi by 2. So sine pi by 2 is 1, so it will be root 2 minus root 2, it will be 0. So it is in 0 by 0 form. Okay, now I can rewrite the function or the question h okay. Now it will be root 2 sine 2x minus root 2. So if we see carefully, then the numerator of this the question or this function, total function, is likely of this, it is in this format. Okay, that is, for this question, if we relate this question, if we relate this question or this format to the this generalized format, then we can conclude that it is our, okay, f of x, required f of x, and root 2 is our required c. Okay, now I am just talking about the numerator of this format. So I can see that the cos x plus sin x is our required f of x and root 2 is our c as per this, okay, this note. Okay, and one more thing I have to check is that whether this condition holds or not, this one. So what I will do, I will just put limit x tends to pi by 4, f of x should be equal to c. Okay, or f of x is what? Cos x plus sin x, and when x tends to pi by 4, cos x will be 1 by root 2 and sin x will be 1 by root 2. Then it will be root 2. Okay, so this, okay, this one also holds true. So in order to apply this result, I have to make sure that the denominator is also in the proper format. It means I should have, okay, f of x minus c should be in the denominator of the numerator here. Okay, so what I will do, I will just divide the numerator and denominator by f of x minus c. Okay, so here f of x minus c is cos x plus sin x minus root 2. It is f of x to the power n minus c to the power n. So I will divide with f of x minus c, that is cos x plus sin x minus. Okay, now I have to divide this with the denominator as well. Okay, so I have divided the numerator and denominator by cos x plus sin x minus root 2. Okay, okay, then if we see carefully, then our numerator in the format, okay, it is in the appropriate format of, it is in this appropriate format. So the limit of the numerator will be this one, n into c to the power n minus 1. Here n is 7. So if I apply, okay, let me write it clearly once more. Limit tends to pi by 4, it will be I'm just rewriting the question. So it will be root 2 sin x minus root 2. Okay. So the limit of this one will be what? N into c to the power n minus 1. So the limit of this one will be limit x tends to pi by 4. Okay. The limit of this one will be what? N into c to the power n minus 1 into this one. Okay, here it is sine 2x, sorry. So it will be this one. So just taking the constant terms outside the limit, then it will be what? 7 into root 2 power 5. Now limit x tends to pi by 4. The rest of function will be sin x minus root 2 divided by sin 2x minus 1. Okay. So when x tends to pi by 4, it will be what? The numerator will be, okay, 1 by root 2 plus 1 by root 2, it will be root 2. And root 2 minus root 2, it will be 0. And when x tends to pi by 4, sin 2x will be 1. Okay, so 1 minus 1 will be 0. Now it is in the 0 by 0 format. So now I will apply the L'Hospital rule here. So in L'Hospital rule, I have to differentiate the numerator and denominator separately. So it will be minus sin x plus cos x okay, cos 2x. Okay, now please two. Okay, cos 2x is what? Cos square x minus sin square x. So it will be 7 by 2 into root 2 power 5. Okay, here I take this 2 outside the limit. Okay, then it will be limit x tends to pi by 4 cos x minus sin x, okay, divided by cos x minus sin x. Okay, here it is in the format of a square minus b square. So it will be a minus b into, okay, a plus b. Okay, so you can cancel out this term, and by when we apply x tends to pi by 2 in this place of x, then it will be 1 by root 2, 1 by root 2, it will be, okay, only root 2. Okay, so it will be 7 by 2 into root 2 power 5 into it will be 1 by root 2. Then by solving or this one, it will be 14. Okay, so 14 will be the correct answer. Now we'll see another question. Sorry. So the question is that beta equal to limit x tends to 0 alpha x minus e to the power 3x minus 1 alpha x e to the power 3x minus. So that is, and here alpha belongs to real number. Then the question is, then the value of alpha plus beta. Okay, so question is this, given that limit x tends to 0, okay, limit of this function is beta and alpha belongs to real number, then he is asking about for the value of alpha plus beta. Okay, this question was asked in JEE, okay, 2021 and 2022 also. Okay, it is a repeated question. Okay, so we are going to use the L'Hospital rule in this question. Okay, so limit x tends to 0 alpha x minus e to the power 3x minus 1 divided by alpha x into e to the power 3x minus 1. Okay, when x tends to 0, you can see that the numerator tends to 0 and the denominator also tends to 0. So it is in 0 by 0 format. So we can apply the L'Hospital rule directly. Okay. Then now taking 1 by alpha outside the limit, then it will be 1 by alpha. Okay, limit x tends to 0, so it will be 1 minus 3 into e to the power 3x. Sorry, it is alpha. So now differentiating the denominator, okay, then it will be okay. So now when we will apply x tends to 0, then the denominator reduces to, okay, 0. The denominator, okay, here the denominator term, I'm just talking about the denominator. Okay, this denominator tends to 0 when x tends to 0. So if when x tends to 0, if the numerator is something a non-zero value, okay, then non-zero value and denominator is 0, then a constant divided by 0 is equal to infinity. Then the limit will not exist. If it happens that when x tends to 0, denominator tends to 0, it is clearly we can see. So the denominator will be 0 when x tends to 0. And when x tends to 0, if the numerator, if okay, if the numerator is a non-zero value, okay, when x tends to 0, it will be what? The numerator will be convert to, sorry, when x tends to 0, the numerator will be reduces to what? Alpha minus 3. Okay, so as we don't know the value of alpha, so if we take it that alpha minus 3 is a non-zero value, then when x tends to 0, the function will be reduced to this format. Okay, if we assume that the numerator is non-zero value, okay, then it will be non-zero divided by 0, so it will be infinity. Something divided by infinity is infinity. Then, but it is not possible as the limit of this function exists and it is a finite value, that is beta we are given here. Okay, so from the question or the given data, it is clear that the limit of this function exists. Hence, we can conclude that as the denominator is 0, to further we to solve this question, the numerator has to be equal to 0. Okay, so from here we can conclude that alpha minus 3 has to be equal to 0, which implies alpha is equal to 3. Okay, if it happens, then this question will be convert to, okay, 0 by 0 format. Then again we can apply the L'Hospital rule. Okay, so let me write properly. So from here we got the value of alpha is 3. So we have, okay, alpha is outside the limit, so it will be 1 by 3. We can write, okay, limit x tends to 0, it is alpha minus, okay, 3 into 3x e to the power 3x we are given. Then e to the power 3x minus 1 plus 3x e to the power 3x. Okay, so the question is in this format now. Then as the value of alpha is 3, okay, now I can directly put here, I should, instead of writing alpha, I should put, okay, I should write here 3. Very clear? Then taking 3 common from the numerator and taking outside the limit, then we can cancel out 3 with the common 3 that we have taken from the numerator. So again we can write here as x tends to 0, it will be 1 minus e to the power 3x divided by power 3x minus 1 plus 3x e to the power 3x. So now when x tends to 0, this function will convert to the, or reduces to the 0 by 0 form. Then now we can apply again the L'Hospital rule. We'll apply here again the L'Hospital rule. Okay, that is, if I apply again the L'Hospital rule, then it will be, okay. Okay, now putting, okay, now applying this limit, this will be, the numerator will be, okay, minus 3 divided by, it will be 3 plus 3 into 1. So it will be minus 3 by 6 minus 1 by 2. Okay, so here you can see that the limit of the function was initially given beta to us. So we got the value of beta by evaluating the limiter. So beta is here minus 1 by 2. and earlier we have evaluated the value of alpha as 3. So now we can find out alpha plus beta, do 3 minus 1 by 2, okay, and it will be 5 by 2. Okay, this is our final answer. Okay, now we'll see another problem that was asked in JEE 2022 and 2021. So the question is, if limit extends to 0, okay, let me use a different color for this question portion. Okay, mm, mm, okay, this one is good. Let me write. Okay, if limit extends to 0, alpha e to the power x plus beta e to the power minus x plus gamma sin x divided by x sin square x is equal to 2 by 3. Okay, where alpha comma beta comma gamma belongs to R, then which of the following is not true? Okay, so now I'm writing the option. Alpha square plus beta square plus gamma square equal to 6. Okay, so this question was asked in 2022 and 2021, both. In both the year this question was asked. So let us see the question once again. Okay, here we are given a function, and the limit of this function when x tends to 0 is given as 2 by 3, and here we are using alpha, beta and gamma are 3 constant. They belongs to a real number set. Okay, it means alpha, beta, gamma are real number. Okay, then the question is that which of the following statement is not true. So in order to answer this question, we need the value of alpha, beta and gamma. Then only we can conclude, okay, that which one is true or not. So we will try to evaluate the value of alpha, beta and gamma from this question. Okay, so just I am writing the above limit. Okay, limit x tends to 0, Okay, it is given as 2 by 3. So now what I will do, I will do so I will just multiply x square. I will multiply x square and divide x square to the denominator. That is, I will multiply x square to x sine x and divide x square here. Okay, so okay, this one. So I can apply the limit, the standard trigonometric limit, that is, okay, sine limit x tends to 0, sine x by x is equal to 1. So I am applying this formula here. By applying, we can say that the limit of this function will be 1. So the resultant function will be, okay. So one important question arises here, that why I did so. Okay, okay. So it will be x cube. So now in limit, I can say that it is in 0 by 0 format. Initially it was in 0 by 0 format. So initially it was in 0 by 0 format. This section, this one, it was initially in 0 by 0 format. Okay, if someone decided to apply El Hospital rule, then by seeing the numerator or denominator, we cannot conclude that how many times we have to differentiate. Okay, by seeing the numerator or denominator, we cannot conclude that if we are going to use El Hospital rule, then how many times we are going to use it. So by doing this, okay, by multiplication, when I multiply x square and divide x square to the denominator, then I got x cube in the denominator. Then if someone decided that he has to apply El Hospital rule, then he can say that yes, I have, if I am going to apply El Hospital rule, then I have to differentiate the numerator and denominator 3 times. Okay, so now I am going to apply El Hospital rule. Why I am going to apply El Hospital rule? Okay, this denominator function is in x square. So if if we are saying that it is in 0 by 0 format, the numerator also has to be 0. So it means limit x tends to 0, that alpha e to the power x plus beta e to the power minus x plus gamma sin x is equal to 0. Then only we can say that when x tends to 0, this function is reduces to what? 0 by 0 format. Then when x tends to 0, it will be alpha plus beta is equal to 0. So from here we got one relation between alpha and beta, that is alpha plus beta is equal to 0. So I just name equation 1 to this equation. Now I will apply the El Hospital rule. So I will differentiate the numerator and denominator separately. Then it will be 5 to the power x minus b to the power minus x plus gamma okay 3x square. So what can we do now? Now again we will apply when we'll check. Okay, when x tends to 0, what will happen to this function? So the denominator is clearly, we can see that the denominator also tends to what? When x tends to 0, we can clearly see that the denominator tends to 0. Okay, in order to achieve this 0 by 0 format again, the numerator okay also has to be 0 when x tends to 0. Okay, if denominator or sorry numerator does not tends to 0, if it tends to some non-zero value, then it will be constant by something constant by 0 or a non-zero value by 0, which reduces to infinity. So it will be, then we can say that the limit of this function does not exist, but it is not true. Initially we are given that the limit of this function is a finite number, that is 2 by 3. So one thing is very clear, that the limit of this function is going to exist, and for the existence of this function, it has to reduce the 0 by 0 form. Okay, so the denominator is in 0 form already, so the numerator will convert to the 0 form. So now it is clear that limit x tends to 0, alpha I to the power x minus beta I to the power minus x plus gamma cos x is equal to 0. Okay, then alpha minus beta plus gamma is equal to 0. Okay, so here we got another relation between alpha, beta and gamma. Now we are going to apply again L'Hospital rule. So it will be 5 to the power x e to the power minus x gamma sin x, and it will be 6x. Okay, again I apply L'Hospital rule to this step. Okay, so it reduces to this one. So clearly I can see that when x tends to 0, denominator tends to 0. So for the existence of limit, it has to be 0 by 0 form. So the numerator has to be 0. Okay, so from here I can conclude that limit x tends to 0, alpha I to the power x plus beta I to the power minus x minus gamma sin x is equal to 0. It means alpha plus beta is equal to 0. Again I got this. Okay, okay, it was, we have already received this relation. Okay, so I'm not counting this equation as a separate. So as it is in 0 by 0 format, I am going to apply again the L'Hospital rule. So it will be alpha to the power x divided by 6. Okay, so now I can see that when x tends to 0, the denominator is a non-zero value. So we can directly put 0 in place of x. Okay, then it will be alpha minus beta minus gamma divided by 6. Okay, initially we are given that the limit of this function is okay 2 by 3. It is very clear that 2 by 3. So it will be 2 by 3, which implies we can say that alpha minus beta minus gamma is 4. Now here we got another equation. So I will just rename this equation as equation number 3. So now I will write all equation together. Then it will be alpha minus beta plus gamma is equal to 0 is equation number 2, and alpha plus beta is equal to 0. It was our equation number 1. Now solving these three equations, we will get the value of alpha, beta and gamma by solving these three equations. So from here we can say that alpha equal to minus beta. Now after getting alpha equal to minus beta, we will apply this in these two values. So it will be what? It reduces to minus 2 beta plus gamma equal to 0. Equation 2 reduces to this one, and equation 3 will reduce to what? Minus 2 beta minus gamma is equal to 4. Now by adding these two equations, what we'll get? Minus 4 beta is equal to 4 and beta equal to minus 1. Okay, as beta equal to minus 1, putting here, then we'll got what? Alpha is equal to what? Minus beta. So minus of minus 1 will be 1. Now putting alpha beta, we got the value of alpha and beta. Now putting in equation 3 or 2, then we will get the value of gamma. So by putting alpha, the value of alpha beta in 3 or equation 2, then we will get the value of gamma as minus 2. So here we have three values, that is the value of alpha, beta and gamma. Okay, now we are going to, now we'll check. Okay, so now we'll check here. Okay, now I'm just writing the value of alpha equal to what? 1, beta equal to minus 1, gamma equal to minus 2. Now we'll verify our options here. So by verifying, we can conclude, okay, that statement 1 is true. Okay, statement D, that is option D, is also true. That is alpha square will be 1, beta square will be 1. Okay, it will be 4. Okay, option B also holds true. So from here we can see that option 3 does not hold true. Okay, by putting you can check or verify. Okay, so that's all for today. We have some another problems that we will discuss in later videos.